if you are not like actually trying, then I made this video for nothing because you're just looking at the answers and that's not really helping anyone. So please, please, please try to do your best and like actually try. So look at the problem, pause it, and then come back to it and see if you did it right. Here's your first problem. This is all kind of like a recap from yesterday. So go ahead and pause it, look at your notes, and come back for the answer. Here is your answer. What is the difference between distance and displacement? Well, distance is a scalar quantity. It's just an amount. It's how far it is between 2 points, okay? So I could say like, let me get my my pen ready. So like I could say, how far did you run yesterday? Well, I ran 2 kilometers. That's not very far. And that would be a distance, okay? Displacement is a vector, and it's a straight line from the starting point to the ending point. So it has to have direction. That's what makes it a vector. So if I said, you know, we are 4 kilometers to the east, okay? And I always show a vector by drawing an arrow over it. So that would indicate that it's a vector. My mouse drawing is not the best, so just bear with me, and I'm sorry. All right, so the next one, how do you solve for displacement in a straight line? So you have one of two situations. If you have displacement and they're both going in the same direction, like say, you know, we traveled 2 kilometers and then we traveled 2 more kilometers in the same direction, we would add them. So if it was 2 and 2, that would be 4 kilometers. And that would be, you know, we could say that's to the east or to the right or whatever direction that is, okay? Now, sometimes you'll have something go this direction. So say something travels 3 meters this way, and then it comes back, whoops, and it travels 2 meters that way. Your total displacement for this would be just 1 meter. And we would say to the right or to whatever direction is given. Okay, the last one, how do you solve for displacement when the path is not direct? When the path is not direct, but it forms like a right angle. So say we traveled north, and then say we traveled west, okay? And our displacement, like if this is our starting point and this is our ending point, our displacement would be from here to here, okay? And that's what we would want to know. So say, you know, like this has a number and this has a number, we want to know this guy. That's when we would use a squared plus b squared, and that's going to equal c squared, okay? You're gonna need a calculator soon, so get one now or either before the next problem. You shouldn't need one for this one, but I do have calculators on my shelf. If you want to borrow one, just please put it back since I'm not there to, you know, pick up after you guys. Or you can use your own. All right, so go ahead and pause it and come back for the answer. All right, here's your answer. Amy runs 2 kilometers south. Okay, we always draw these. So that would be 2 kilometers, and she runs to the south. And then she runs 2 kilometers back the other way. Okay, so we've got 2 questions. Sorry, my kilometers should be after my 2. But my two questions, what is her distance, total distance traveled? This is really straightforward. She went to this way, and then she went to the other way. So that's a total distance of 4 kilometers, okay? Then it says, what is her displacement? So how far is she from her original starting point? Well, her original starting point is here, and then she came back to her original starting point. So her total displacement would be 2 in one direction, but she came back the opposite direction, so it would be 2 minus 2. So her total displacement is going to be 0 kilometers. And we don't need a direction because it's 0. So there you have it. All right, go ahead and pause it. All right, here's your answer. John runs exactly 2 laps around a 400-meter track. So you have a track, and that track is 400 meters. I guess that's pretty standard. That'll be important later. And he runs 2 laps around it. So he goes around it once and he goes around it twice. So what's his total distance? His total distance is 800 kilometers. And then his displacement, how far is he from his original starting point? Well, John came back to his original starting point. So displacement is 0, not 2. 0 kilometers. Go ahead and pause it. Try to solve it. Okay, here's your answer. Derrick. I'm not exactly sure why Derrick is crawling, but he is. But he's crawling 4 meters to the south, and then he turns east. Why are you crawling, Derrick? That's weird. And then he goes 6 meters this way, okay? And I should have added, I want to know distance and displacement on this, just like the others. So total distance Derrick traveled would be 11 meters. But his total displacement is from this starting point to this ending point, and that's what we don't know. So that's when we use that Pythagorean theorem. So a squared plus b squared equals c squared, and our unknown is that c squared. So this would be this weird guy Derrick. This would be, oh, and you know what? I said 11, and it should actually be 10 because I drew my diagram wrong. I apologize. Bear with me. All right, 6 and 4. All right, so now we have our correct a squared and b squared. So this should be 6 squared plus 4 squared, and that's going to give me c squared, and that's what I'm looking for. All right, so that would come out to 36 plus 16, and 36 plus 16 is 52, and 52 is equal to c squared, but we're still not done because I've got to get the square root of 52. So the easiest way to do this is punch 52 into your calculator and then hit the square root button. And from that, you should get the displacement of 7.2 meters. But remember, displacement is a vector, and which direction do we go? That's when we go back to the problem. And he went south, and he went east, so his total displacement would be 7.2 meters southeast. That's the direction he went. All right, question number 5. Go ahead and pause it. Here's your answer. We've got to draw a picture, and this one is not making a right triangle, so this one actually ends up being a little easier. So he runs, this guy runs, at least he's running and not crawling, 30 meters to the north, and then he runs 30 meters to the west, and then he runs 30 meters to the south. So this is pretty straightforward. And this is why we always draw a diagram, because the words, sometimes it's confusing, but if you write it out, you can actually see what's happening. So his total distance should be 90 meters, 30 plus 30 plus 30. And then his displacement is, well, okay, he started here, that's his starting point, and then he finished here, that's his ending point. So basically, we want to know how far is he? Well, we already know that. He's 30 kilometers, or oops, not 30 kilometers, he's 30 meters. He didn't go that far. And he's 30 meters to the west. All right, moving right along. Derrick walks 3 kilometers north, turns east, walks 4 kilometers south. Don't forget to pause it. Okay, here's your answer. 3 to the north, 4 kilometers to the east. Okay, so I make a right angle, so I know I'm going to use that Pythagorean theorem. So total distance traveled is going to be 7 kilometers. That's a 7, by the way. I don't know what's happening. There we go, 7 kilometers. But then I want to know what this displacement is. Okay, Pythagorean theorem. So 4 squared plus 3 squared. Okay, and that's going to be 16 plus 9. This was the easy one like we did. And that's c squared. So yesterday we solved a problem very similar. 25 equals c squared. So basically your displacement is going to be 5 kilometers. Okay. And what way did he go? He went north and he went east. So there is your direction to make that a true vector. All right, problem number 7. Go ahead and pause it. Here is your answer. All right. So Michelle, she walks 100 towards the west, 100 meters. Okay. And then turns and walks back. So we've got 100 and she walks back 20. Okay. And that's in meters. And so her total distance, this would be 120. And then her displacement, don't forget your unit, no naked numbers. Her displacement is going to be 100 minus 20, so total displacement is going to be 80 meters to the west. Go ahead and pause it. Okay, here's your answer. This one's a trick question. I apologize. An Olympic runner competing, they did complete, the 1600 meter circles the track 4 times. Well, the 1600 meter is 4 times. So if you think back to that earlier problem, if you're not a track person like me, a track is 400 meters. And their event is called the 1600 meter. So what is his distance? That is already answered for you. Sorry. 1600 meters. I would not do this to you on the test, by the way. Just want to get you thinking, wake you up. And his displacement, well, that's easy. It's 0 meters because it's a track. It's a circle. They came back to where they started. Almost there, guys. Number 9. This one's really, really complicated. Not that complicated, but you just got to follow instructions and be methodical about it. So this is where a picture is really going to come in handy, and you will have one similar to this on your test. So like I said, draw a picture. So shopper walks forward 200 meters, and then they turn right, and they walk 5 meters. And then they turn left, and that's confusing, like I wouldn't know where to go, but it says they walk in the original direction. So that would be the first line that we drew in that same direction, and they do that for 10 meters. And so after that, then they turn left again for 5 meters. And that's kind of tricky because they turn left and go back that same direction. So the first thing we have to figure out is what's their distance. Well, that's pretty easy. 20 plus 5 plus 5 plus 10, or whatever order you do it in, and you get a distance of, that's 40 meters. But the displacement is where it gets tricky. But this is why we draw a diagram. Okay, so remember, opposite directions we subtract, same directions we add. So these 5s, they're in opposite directions. So they totally cancel out. 5 minus 5 is 0. So we can eliminate those, and that makes it a lot simpler. So we have a 20 and a 10, and they're going in the same direction. So 20 plus 10, her total displacement is 30 meters. Now, they didn't give us a north, south, or an east or a west, and it says forward. So we would just say 30 meters forward, or we could say 30 meters in the original direction. That would work for a direction. Forward. This is awful. Okay, there we go. We got it. All right, last problem. And then I've got a couple YouTube videos for you that are not me, and they're much better productions. And that's it. All right, so this is another good one where it's good to draw a picture. So go ahead and pause it, draw a picture, solve it, and then come back to the answer. Okay, guys, so here's your answer. Some hikers, they travel north. Hopefully this is not you, because it sounds like these hikers are lost because they're going to go in a circle. They travel north 2 kilometers. Then they turn toward the west, and they travel 4 kilometers. And then they turn towards the south, and they travel 6 kilometers. But then they finally travel back east. Uh-oh. Oh, that's a crazy arrow. 4 kilometers. Okay. So first of all, what's their distance? Well, you would just add up those sides. So 6 plus 4 plus 4 plus 2. And you're going to get, what is that? 16. All right, so distance is 16 kilometers. That's a pretty good distance. That's a pretty good hike. Maybe they would hike less if they weren't going in circles. All right, what's their displacement? Well, remember, these fours. One is west and one is east. They're in opposite directions, so we can just cancel those guys out. Now, these are also in opposite directions, but they aren't the same number, so we just subtract the smaller number from the bigger number. And so that would be 6 kilometers to the south minus, and you can even write out, like if you have the directions, that even helps you more. So 6 kilometers to the south, I promise you that's an S and not a 5, minus 2 kilometers, and those were to the north. Your displacement is actually going to be 4 kilometers, and those are to the south. Right, great news. We made it. We did the 10 problems in my terrible handwriting, and now you've got some practice under your belt. So there are 2 other videos below this video on Canvas. I want you to watch them. It's they're cool. It's Crash Course Physics, and it's a new person. It's not that same Hank or John Green or whoever that guy is. It's a new person. So enjoy those and jot down in your notebook like a couple cool things you learned. If you don't totally finish the videos, it's okay. Just do your best to get as far as you can. All right, thanks guys, and I hope to see you tomorrow.